7th grade math, chapter 8, section 1, points, lines, planes, and angles. Our first vocabulary word is the word point. A point names an exact location in space. It is so tiny it has no width or height. There is no dimension. And we label it using a letter to describe it. I could have point A with the symbol dot, or I could write the word point and then specify which point I'm talking about with a letter. Our next word is line. It is a perfectly straight and extending forever in both directions. It has one dimension, length only. It has no thickness. We have a line here with 3 points on it. We have point S, point B, and point W. If I were going to choose 2 points and talk about that line, I could choose point SB, I could choose point BW, or I could choose points S and W. You'll notice when I wrote the letters, I also put a symbol on top. The symbol has arrows on both sides, indicating that that line will extend forever in both directions. Our next term is ray. A ray is a part of a line that starts at one point and extends forever in only one direction. Think of a sun's ray, if you would. So I am going to choose point S, and I am going to talk about the ray that continues on in the direction of B and W. So I could make my ray and talk about ray SB, and that actually is the same as ray SW. So a ray has one arrow on one side, showing that that line or ray continues in only one direction. Our next word that we're going to talk about is segment. Think of like an orange segment, which is a piece of the orange. So a segment is a part of a line between 2 points, which means that that is a line segment that has a starting and a stopping point. So if I go back to my line up here, I could talk about the segment just between S and B, and I would label it with a line on top with an S and B underneath. Notice I do not have arrows, which means the line stopped at B and started at S. I could also have segment SW, which meant it started at S and ended at W. That is a line segment. Let's scroll down the page here and look at the next section. We have the definition to plane. Plane is a perfectly flat surface that extends forever in all directions. Now this that we're talking about does finally have our 2 dimensions. It does have length and it has width. It has length going this way forever and width going this way forever. So think about a piece of cardboard, all the different points that are on that piece of cardboard. Let's think about some names for the points. We could label point C, we could label point P, let's have point F, and how about point L? So if we're going to name our plane, there is no symbol for that. We just have to write the word plane. And then we choose any 3 points we want. Well, I like points C, P, and F. So when I label a plane, I have to write the word. There's my word plane. And then I can choose any 3 points. How about L, F, and P? Our next definition is a very familiar word to you. It is congruent. That means to have the same size and the same shape. When we think about congruent objects in geometry, we can talk about segments, we can talk about angles, we can talk about shapes. Anything can be congruent in geometry. So let's look at our picture down below. We are using slashes to show some line segments that are congruent. I could see one slash and one slash, and that means that those two lines are congruent. They are the same length. I can also see two slashes and two slashes there. That means those two lines are congruent. They have the same length. Now we have three slashes, three slashes, three slashes, and three slashes. That means all four of those line segments are congruent. They have the same length. So I could label line segment BF is congruent to line segment DF. Our symbol for congruence is an equal sign with a squiggle on top, kind of like what you make when you write the pi sign. Another set of line segments that are congruent could be line segment AC is congruent to line segment BD. You'll notice each thing that I'm labeling has its symbol on top of it. Line segments, because none of these continue in all directions or even one direction. Another set of congruent lines IC could be line segment AB is congruent to line segment CD. AB is congruent to line segment CD. Our last definition for this section is vertical angles. Vertical angles are easier to think about if you think about colors. What they're saying is when we have two intersecting lines, we have vertical angles that are always congruent, which means they are always the same measure. So if I were to measure this angle, angle FSG, and it looks pretty acute to me, so I'm going to say it's 45 degrees. The angle that is vertically across from it, angle HSK, also is 45 degrees. They are congruent. They are the same measure. And so if I look at the angle HSF, it will be the same measure as its vertical angle, which would be KSG. Let's say this is 135 because that looks pretty obtuse to me. So this angle also would be 135 degrees. So I could write angle HSK is congruent to angle FSG. I could also say angle HSF is congruent to angle KSG. That's the conclusion of points, lines, planes, and angles.